So hello guys, today we are going to do a Leetcode question that goes by the name Isomorphic Strings. Question number is 205 and it's an easy question. It is today's Leetcode daily question. Okay, so first we are going to read the problem statement and then we are going to go to the solution. Okay, so let us first try to read the problem statement and then we will just see if we can arrive to the solution or not. Maybe, who knows, who knows. Okay, so I'll just try to read the problem statement once. Given two strings s and t, determine if they are isomorphic. Okay, so as you can see, I are given with two strings s and t, and you have to determine whether these strings are isomorphic. Isomorphic. But what is this isomorphic? Okay, two strings s and t are isomorphic if the characters in s can be replaced to get t. Okay, two strings s and t are isomorphic if the characters in s can be replaced to get t. As simple as that, all occurrences of a character must be replaced with another character while preserving the order of characters. No two characters may overlap to the same character, but a character may map to itself. Basically, I'll just try to give a brief explanation of the question. What the question is trying to say. So let us first consider this test case. Okay, EGG Okay, basically it is given like EGG, EGG, and it has to be converted to ADD. Okay, what it is saying that, what the question is saying that you are given with this and you have to get this. You have to get this. Okay, so what you are given this, basically you have to convert this string such that you have to replace the character such that this string is formed. This string is formed. Okay, so I can replace it with any elements. Okay, so if I in this string I replace E with A and G with D, can I get the same string as this? Because E with A becomes A and then G with D becomes G. So ADD. Is it the same string as this? Same string as this? Yes, yes. Okay. So this is what the question is trying to say. This like, and if it is following the conditions, then it is isomorphic. Okay. All occurrences of a character must be replaced with another character while preserving the order of the characters. It simply means that the character should be in the same order. The character should be in the same order. Okay. No two characters may map to the same character. Okay. But a character may map to itself. Okay. So basically, it is trying to say that like G cannot be mapped to F and G cannot be mapped to C. Like this cannot happen. One character should contain only one mapping. Like if G should be marked with D, then it should not be repeated again. It should not be repeated again. Okay. So if I just try to see the another test case, PAPER and TITLE. Okay, PAPER and TITLE. Okay, this is what I am given with, and this is I have to get. So can I make this string equal to this? Basically, if I just replace P with T, A with I, E with L, and R with E, okay, can I get the same string? Because P basically becomes G, A becomes I, P becomes again T, E becomes L, and R becomes E. Are the rules being followed? Are the rules being followed? Yes, because there is only one mapping and there are no overlapping as such. Okay, so yes, it is following. So what I'll return? I'll simply return true. In what cases will my condition fail? In what cases will I return false? Basically, just see like this. If I'm given with something like FO and BAR, okay, this is what I am given with. This is what I am given with, and this is what I have to get. This is the output. Okay. So is there any mapping I can do to make this equal to this? Let's try. Simply, if I can just replace F with B. If F with B, okay, like F would be converted to B. But what about this? What about this? I have to make another mapping like O should be mapped to A. But then again I have to write O should be mapped to R. Is this just disobeying my rules? Yes, because I cannot map a single character to other characters, to two other characters. I have to mark it to a single character only. So in this case I'll return false. So this was the question about. So let us just get with the approach, but before we'll just try to make some observations. Okay, we'll try to make the observations. What I can observe. Basically, I have to just replace the characters. I can replace any characters with any character, okay, and any number of moves are possible. So what I can simply do is, just if I just compare the first test case, just see EGG and ADD, EGG and ADD. Okay, if I'm just following by the rules that there should be no overlapping, and the characters should be mapped to a single character only. Single character. A single character should be marked to a single character. Okay, like this G cannot be like marked like this. G should be marked to F and G should be marked to C. This cannot happen. This cannot happen. Okay. So only if G is marked to D, then only this rule can be there. This rule can be there. Okay. So if you just try to observe, if I just order them according to their indices, 0, 1, 2, and in this also 0, 1, and 2. So if you will just observe the characters, the characters are same at the indices. Basically, at 1, 2, the characters are same. At the index 1, 2, the characters are same. Basically, this is G and D are not equal. If D is at position 1, then D is also at position 2. And in this also, if G is at position 1, then G is also at position 2. So as you can see, you can just observe a pattern that similar character are mapped to the same indices. Basically, if G is occurring, like there is a duplicacy of G, at the first and second index. So here also there is a duplicacy of D at first and second index. Okay, and this is necessary because see if suppose there is no duplicacy here, and D and C would be here. So D would only be present at one, but G would be present at both the places. So I cannot replace the G with C. I cannot replace the G with C because this means that I have to map G with D and I have to map G with C. I have to do both of these, but this is not possible. This is not possible. So I just conclude. I can conclude that for any validation, that for any string to become valid, follow the condition, to follow the condition whether it would be mapped to the another string, is that basically all the characters repetition or the pattern that the strings are following, should be same. Pattern should be same. If the pattern is not same, that means like suppose if there is a unique element here, there is a unique element at the 0th index here also. Okay, it cannot be repeated again. This A cannot be present here, because if this A can be present here, then it would be just disobeying my basic rules, and this is not possible. So both of these both of these should be following only one pattern. Okay, only one pattern. So I just mean to say that if 1 and 2 in string 1, if 1 and 2 contains a digit G, so in the string 2 also, not basically the same character, it can be C also. Okay, but 1 and 2 should be occupied by the same element, so that I can just map G to C and it can make my conversion possible. Okay, I can just tell you with another example. Suppose let us take this third test case. Okay, PAPER and TITLE. PAPER. Okay, and then TITLE. Okay, if I just map the characters with their elements, okay, I'll just make two maps. This map will be storing the frequency, like the indices at which the particular character is present, and this map will be storing the indices at which particular element is present. Okay, so P is present at what indices? P is present at 0 and 2. Okay. Where is A present? A is present at index 1. E is present at index 3. R is present at index 4. Okay. And for this, T is present at index 0 and 2. T is present at index 0 and 2. Okay. I is present only at index 1. Only at index 1. L is present at only at index 3. L is present only at index 3. And E is present only at index 4. Okay. E is present only at index 4. And E is present only at index 4. Okay. So I can just see that both of these are following the same pattern, because see, if P is occurring here at 0 at 2 index, T is occurring at 0 at 2 index. Okay, so element, the character might not be same, but the indexes at which that particular character is occurring is same. Basically, if T is being repeated here and here and here and here, basically they are following the same pattern. Basically they are following the same pattern. So I can just map my P with T. P with T. Okay, if my first index is just followed by A and here my first index is followed by I, so I can just convert my A to I, and for this I can convert my E to L, and for R I can convert my R to E. Okay, so if I just follow this mapping, my P is converted to T, A is converted to I, P is again converted to T, E is converted to L, and R is converted to E. What I can get is, I would get this particular string. Now I'll just try to see. Okay, the third test case. Okay, and basically I don't have to retain the full order. Just see. This is the approach basically I'm telling. Okay, so for P, okay, and for T, I can basically have it in one go. Okay, so in one go, what I'll check is I'll just check with previous occurrences of P and T. Okay, so basically for my first index, is P occurring before? No. So what would be stored in this? 0, and for this also 0. Okay, so both of these are not present. Okay, okay, but now they are present. I'll store them with index I plus 1. Okay, basically if I'm at 0 at index, I'll store them with plus 1, basically 1. Okay, okay, makes sense. I'll tell you why it makes sense. Okay, I'll store it with just 0 plus 1 index. Okay, so I'll store P at index 1 and T at index 1. Okay, I'll just move forward. My pointer is here, and my this and for T also my pointer is here. So is A and I present in any of the maps? No, no. So I'll just store it. A will be stored at index 1. I will be stored at index 1. It is following the condition, because there is not been a single mismatch till now. Okay. Now when I come to P, and when I come to T, okay, I'll just check with its previous occurrence. Are the previous occurrences same? Why I don't have to check all the occurrences? Because see, if I'm just checking for previous occurrences, if there is a P here and there's a T here, okay, if I am checking for this indexes, I don't have to compare it with this. Basically, see, PAPER, right, and TITLT. Basically, if it was like this. Okay, so if I'm already checking P and P, then I don't have to compare this P with this. Why? Because this has already been checked. And I don't have to compare it with this again, because if these are already being checked, that means they are already in their particular position that they should be present in. Okay, so I just have to check with the previous occurrence, that is this. Okay, just clear the board for you. And this becomes R only, and this becomes E only. Okay, I'm at this index. Now what I'll do is, I will just check with the previous occurrence of T and P respectively. Are they at the same index? I'll just check. It is at index 1. Basically, I will store A with a 2, index 2, and I with a index 2, basically plus 1. Okay, because it is present at index 1. So I'll store it with index 2. Okay, are they present in the map at the same index before? Yes, because it is present at 1, it is present at 1. Okay, so they are following the pattern, they are following the pattern. I'll just move forward, I'll just move forward, I'll move to this index, I'll move to this index. For this also I'll move to this index. Is E present in my map before? If is E present in my map before? No, no. So let's see why I am using this I plus 1. Because see, if when I am checking for a new element, when I am checking for a new element, what I will find is, the map will find it with a frequency of 0. But the map will find it with a frequency of 0. So if if I store this with a frequency of 0, like with the index 0, with index 0, basically, like see, this would be stored with the index 0 by default, because it is not present, so it is stored at the index 0. So if I just store it with the index 0, this would overlap. This would overlap. Okay, and this would be failing my condition. This would be failing my condition. So I'm just storing it with +1 so that 0 doesn't get overlapped. So is E present? Is E present in my map? No, it has an index of 0 as of now. I'll just store it with I plus 1. E is stored with 3 plus 1, that is 4. Is L present? No. So they are still following the condition. Okay. I'll just store it with 4, 4, index 4. I'll come to R. I'll come to E. Is R present in my map? No, it has index 0, index 0. So I just store it with I plus 1, that is 5. And I store E with the index I plus 1, equal to 5. So as I'm done with the loop, I can return true. I can return true. Okay, in this case, I'll return true. Why? Because see, all the conditions are fulfilled. All the conditions are fulfilled. I will just check with the previous occurrence. I'll just check with the previous occurrence. I don't have to check the whole array again, whole occurrences, whole elements again. Okay, I just have to check with the previous occurrence, and that would make my work. Because I've already checked with this occurrence, right? If the P is occurring here also, then I don't have to check it again. I don't have to check it again for the next occurrence. Okay. So in this case, I would be returning true. Now I'll tell you in what case it will fail. Suppose I can take this condition foo bar. Okay. FOOBAR. And just remember, we are using two maps. So 0, 1 and 2 are the indexes, and these both are my strings. Okay. This is my first map and this is my second map. Okay, I'll come at index 1, I'll come at index 1. What I'll just see is, I'll come at this index, I'll come at this index. Okay, is f and b present in my map? Is f and b present in my map? No, no. Okay, so what I'll do is, I'll just store it, but with a frequency of 0 plus 1, index plus 1. So f is stored here and b is stored here with an index of 1. Basically, if they're not present, that is, they are following the conditions still. Okay, so I can just store it. Okay, now I'll come to this index, I'll come to the first index, I'll come to the first index, I'll come here, I'll come here. Okay, is O present in my map? No. Is A present in my map? No. So I'll just store it with a frequency of I plus 1. Okay, with the index of I plus 1, and this A with the index of I plus 1. So it is 2. Okay, okay, okay. But when I come to the second index, I can see that R is not present in my map. R is not present in my map. But is O present in my map? Yes. So here I am getting an answer no, yes, and here I am getting an answer no. So this is a mismatch. This is a mismatch. And that you can obviously see because I cannot assign this O to two elements. I cannot assign this O to A and O to R. Okay, I can assign it to only one. Okay, so if it is being present, in this, and if it is not being present in this, okay, that means the pattern is being disfollowed. And this is the case when I return with false. After this, I don't have to check, because if this string cannot modify, this cannot be done. So I'll just simply return false. And I have to I'll check the base case at the first. Just before, after checking all this, I can just add a case that if s dot length is not equal to my t dot length, that is, if both the string lengths are not equal, they cannot be equal at any cost. So I'll return false in this case. Okay, I'll simply try to write the code for this. What I need is I'll first write the condition. If s dot length not equal to t dot length, what I can do is I can simply return false. Okay, then what I have to do, I have to make an unordered map. with char int mpp and then mpp1 for the following maps. For basically I have two strings, so I have to do this, and now I can go to one length of the string because the strings should be equal, then only it will come here, then only it will come here. And if at any point, if at any point my strings are not following my pattern, the strings are not following a particular pattern, I'll return false. And else what I'll store, I'll just store index plus one, index plus one. Okay, why index plus one? Because it shouldn't overlap, with this, it shouldn't overlap with this condition, because if the element is not present, that it would be stored with the index 0. Okay, and you can just see if a character is being stored at element index 0, index 0 is present at the, like a character is present at index 0, so both of them with overlap. Okay, and this is not the case that we want, so I'll just try to run it. Okay, okay, that is mpp1. Okay, I'll just try to run it. Okay, I'll try to submit. Okay, submitted successfully. So if I just try to just explain the code to you. So if the string length is not equal, if the string length is not equal, they can never be equal. They can never be converted to each other. Okay, okay. I'll just declare two maps for occurrence storing, basically index occurrence storing. Okay, and just I'll iterate the string, and if at any point, I see that the strings are not following the order, the pattern, then return false. And then I'll store this with the index of I plus 1 so that it doesn't overlap, with any index. Okay, at the last I'll return true. Okay, if I just try to see the time complexity, see, I'm just traversing only once. Okay, and then I'm not traversing any other time. So what I can simply say is my time complexity is simply O of n, because I'm traversing one. What about my space complexity? Is it gonna be O of 2n? Because I'm using two maps, right? So is it gonna be O of 2 into n? O of 2 into n? No, because we are storing characters, and characters can be 26 at max. So this will be 2 into 26. Okay, two maps will be storing 2 into 26, and that is nothing but O of 1. Okay, this can be converted to O of 1. So time complexity is O of n, and space complexity is O of 1. So this was the overall solution to the question, isomorphic strings. I hope you guys like the solution. If you have any doubts, you can just ping it down in the comments. And if you like the video, just like, share, subscribe. Thank you. Have a nice day. Bye bye.